Hello, my name is Kiera Walker, and I'm going to be answering the video essay questions for Chapter 8. And the first question would be, what steps in protein synthesis are inhibited by each drug? And the first steps for protein synthesis, there are two major steps. There are transcription and translation. Genetic DNA and transcription is copied into a sequence of RNA. Following the cell uses the information to make a specific protein based on the copy information during translation. And the steps for the first drug, excuse me, I have to go to the pronunciation of each word, which would be
ciprofloxacin.
Inhibits protein synthesis by inhibiting the enzymes necessary for carrying out the process of DNA synthesis and replication. DNA gyrase, if I'm pronouncing that right, is one of the major enzymes that is targeted by this category of drug, making it unable to perform its normal duty. And the category of drug it is referring to is quinolones, which the group of drug, I'm sorry, I have trouble pronouncing these words, which is the group of drugs that ciprofloxacin belongs to. And the next drug would be
erythromycin.
And erythromycin, ways of treating microbial infections is to inhibit protein synthesis on the prokaryotic ribosome. Erythromycin attaches to 50S subunit, blocking the protein synthesis. And the next drug would be acyclovir, and it is used primarily against herpes viruses. In protein synthesis, it inhibits the synthesis of DNA or RNA synthesis. Causing a blockage of the DNA process. And the next question would be, which drug is more effective against bacteria and why? Erythromycin inhibits the protein synthesis process on prokaryotic cell ribosomes by binding the 50S portion of the 7S that is divided. It inhibits the information on a wider spectrum, while most drugs are inhibitory on a broad spectrum of activity. And this causes it to be more effective against bacteria. The next question is, which drugs will have effects on the host cells and why? Aclovir, I know I'm pronouncing that wrong, will have no effect on a cell that is not affected by a virus. It will not alter the thymidine kinase which is kinase. It will not change it into a false nucleotide. The DNA gyrase, which is GYRASE, which is targeted by chloro. I know I'm pronouncing this word wrong.
Ciprofloxacin,
which is targeted by ciprofloxacin, causes it to be unable to perform its normal role. Erythromycin only inhibits protein synthesis on prokaryotic cells, which the human does not contain. The humans have eukaryotic cells, meaning it won't have the same process on a human cell. And our human cells possess a different enzyme instead of DNA GYRASE, so it does not have the same toxic effect on humans as bacteria. And the next question is, using the index of our book to identify the cause for clavir is primarily used. Why is it more effective than the erythromycin for treating this disease? The disease that I'm getting the pronunciation of the word.
Acyclovir.
The disease that acyclovir is used for is herpes viruses. Herpes is a virus, and erythromycin works better against bacteria. The acyclovir causes a blockage of the process of DNA synthesis in the infected cell, whereas the erythromycin would target the microbe of the bacteria of the infected cell and not actually the virus itself. And thank you.